Hello guys, can you see the screen share?
Yes po.
Yes, sir. Yes, sir.
Okay, so
Yes, sir.
by the way, while I'm doing this one, I want you to go to the Tinkercad. Uh, I don't know if you can see the URL. Anyway, I'll be sending the URL in the chat. So it's www.tinkercad.com. Okay, Tinkercad. Okay, so I've sent it already in the chat. Okay, I want you to sign up and create an account. Okay, while I'll be creating a class. So, what will be the class for this one? So, TDO or TDO NHS uh, batch 1, I guess. Okay, so grade level. What's the grade level? Is it grade 8, guys?
10.
Grade 10. Okay.
Grade 10 po, sir.
Grade 10, then the class would be something to do with robotics. So grade class. Okay, so I have here the CDO. So I'll be uh, clicking this class code. Then I'll be copying this link, copy link. Then I'm gonna post it in the chat. Okay. So so you're going to do that. Meanwhile, okay, so you create the your Tinkercad account, then the link. Okay, so our first discussion will be on circuits, no? The basic about circuits. So to do that, we need the uh, we need to do some. Okay, so if you're interested, no, while doing you're still completing I've posted a link, Falstad. Okay, so it's a circuit simulator. Okay, so I'm gonna click the zoom. By the way, this falstad.com/circuit is also manageable in smartphones. Okay, you can zoom, but it will be a little bit tricky. Okay, so the first topic would be Ohm's law. But before that, can you see the circuit?
Yes, sir.
Okay.
Yes, sir.
So I'm gonna go to is it draw? Ano? Circuits. Then I'm gonna click this blank, no blank circuit. You need to click first the circuit tab, then you click the blank circuit. Okay, so everything now is blank. You go to click. You're gonna click the circuit again, then you go to basic. So these are the basic things that you need. Okay, before proceeding to uh, further in Tinkercad. So Ohm's law. Okay. Okay. Can anybody tell me what is happening? If you can see the display, the circuit. Can anybody would like to comment on what is happening, or can simply describe what is happening? It's a matter of simple description lang.
The other one, sir, is moving fast and the other is moving slow.
Very good. No. Now, what is this motion all about? No. Does it have something to do with uh, particles? Does it have something to do with dots? What do you think? Just a guess. No. I know that I don't know your background if you have basic electricity, but anyway, let's proceed. Would like to comment what is that moving something? What is that something that is moving slow and moving fast?
The current of the electricity po, sir.
Ah, very good. So you have an idea already of a current. Okay, so a current, it may be described in an analogy as a water current. No, seems to be a water current. No, the left side is flowing very fast. No, while the other side, the right side, is flowing very slow. Okay, so anyway, so it's true, it's correct that this is electric current. Okay, it's also that's an analogy with water current as well. Okay, so can anybody tell me what is Ohm's law? Why is it that the left side is it has a greater moving current, whereas the right side has uh, lesser, moving current? Do you have an idea? What is Ohm's law? Excuse me. Right? Input the text. So nobody knows what it's Ohm's law. Anyway, so Ohm's law. Okay. So it works for the science, the one that invented this law. Okay. But I go directly to the formula. Okay. So I'm going to edit. So voltage is equal to current times resistor. Resistance. Right click, select done. Okay, so it is said by Ohm's law that the voltage is directly proportional to the current, or the other way around. The current is directly proportional to voltage. Okay, then going back to the other way around, it is the because it's a proportionality. Okay, so voltage is directly proportional to current. Okay, so the proportionality constant, no, is said to be the resistor, or the resistance rather. Okay, so the unit of resistance is ohms, no, in favor of the scientists discovered the law itself. Okay, so now who can tell me, based on this equation, why is it that the current in the left side is greater as compared in the right side? Okay, so no, Kwan, no volunteer. Okay, so let's try to uh, solve for the equation of current. Current is equal to voltage divided by resistor. How about this time? Okay, so my question was, why is it that uh, the current is greater to the left as compared to the right equation? So I have now uh, simplified Ohm's law equation in terms of current. Okay, so nobody wants to to volunteer an idea. Wants to give any idea for this matter?
Ako po, sir.
Okay,
The voltage of the
no, the
base
current, no,
kanang
the current. We're talking about the current.
uh,
Okay, it was
yes sir, the
observed that the current on the left side is moving fast or has a greater value. In fact, it's there. It's 50 milliamps. Whereas on the right side, slower and the value is 5 milliamps. Now the question is, why is that so?
because the ano po sir, the di ba ang ano sir is ang current is directly proportional to voltage. So nag-differ sila sir kay ang amount mo sa voltage sir. So if greater ang voltage, greater ang current.
Okay, so let me clear first, no? Uh, by the way, V is the voltage, I is the current, and you have seen uh, on the top of the circuit, no? Can you see it? It's labeled as positive 5B or means 5 volts. So both of the elements are receiving the same amount of voltage. Okay, so in this case, voltage is said to be constant. Okay, so very good observation. Can you further explain your answer, guys? Are you with me?
Yes sir.
Okay, so so let's proceed with the second equation. This one. Okay, I'm gonna try to okay, to move it a little bit. Okay. Equation now is current is equal to voltage divided by resistance. Now there is what is known as inverse proportional, inversely proportional. Current now is now inversely proportional to resistance. Okay. In this case, on the left side, what do you think is the value of the resistance? Just a guess.
The value
1,000
of
ohms, sir.
resistance on the
Come
left side,
again. What's the value of the resistance in the left side?
it's less than compared to the right side, sir.
Now I'm asking for the value, not for the comparison.
100 ohms po.
Okay, very good. On the right side,
1,000.
okay,
1,000.
very good. You can read K. So K means 1,000. Okay, so it's 1 kilo ohm or 1,000 ohms, and the left side is 100 ohms. Okay, since current is inversely proportional, so actually that is the explanation now. Why is it that there is more current in the left side as compared on the right side? Because of the inverse proportionality. Do you know what is meant by inverse proportionality?
Yes, sir.
Okay, so the lesser it is, the bigger the current. Okay? The bigger it is, the lesser the current. So we're talking about resistance. Okay, so what do you think is resistance? Okay, so resistance is actually has something to do with resisting or impeding the current flow. Okay? No, let's put it in an analogy of water tank. Are you familiar with a water tank?
Yes, sir.
Yes, sir.
A
Yes,
water
sir.
tank. Okay, so if you're going to open the valve of the water tank, then simply if it is filled with water, then you're simply let us say it is elevated water tank. Then or the water is the water tank is filled or filled with water. Then if you're going to open a valve, then you are simply allowing current water current to flow. Am I right? Is it true or is it
Yes, sir.
false? Okay. Now, what
Yes, sir.
happens if you're going to resist the flow of the water current? How are you going to do it? Okay. So we're talking about resistance. So how are you going to resist? Okay. The water current.
Um,
Who has an experience resisting water current? Say there's a hose, then you're watering the plants. Can you resist the flow of the water current when you're watering the plant or you're opening the valve of the water
Yes,
tank?
sir.
yes, diba?
So the question is,
Yes.
how are you going to do it? How are you going to resist the water current?
Um, adjusting the water pressure.
I-cover nimo ang you will covering the whole of the hose.
Okay, very good. If you're going to cover, no, if you're going to cover the path, no, or the hose or the pipes, so you're actually resisting current flow. Okay, and similarly, no, similarly in electricity, that is what is also meant by resistance. You're resisting current flow, but in this case, you're not going to cover anything. Okay, resistance is natural in any material. Okay, take note in any material, uh, electrical resistance is natural. No, now you can create your own resistance. No, this is what is known as resistor. Okay, a device, a simple element or a device that has been created, no, to resist current is what is known as resistor. Okay, copy? Is it copy? So
Yes, sir.
the if you're going to look at the figure, no, the resistor, it's a zigzag. Is it a zigzag na symbol? Is it a zigzag symbol?
Uh,
Now, the reason it is a zigzag symbol because it res- uh, it
Yes, sir.
represents no it represents that you're actually resisting no the flow of current. It's just like putting your hands in the covering the pipe. No, it looks like that way. No, or simply you have a traffic. No, if you're going to go to uh, Bukidnon, perhaps Buddha, they have this zigzag road. No, so it will take for you to for a while for you to cross the path because it's zigzag, so it's slowing you down. Okay, now so do you know, so you know now that resistor is a man-made device, no, to generate resistance. Now, who can guess what kind of material, no, that is naturally a good conductor, no, of electricity? No? Uh,
Metal po.
oh, very good. So metal
Metal.
is has naturally lesser resistance. Okay, so it's natural for
Yes.
metal to have lesser resistance, but not all. Okay, take note, but not all metals have less resistance. Okay, now among the conductors, the famous, no, conductor that has less resistance is, who can guess?
Water, sir?
Very good. The copper is a very good conductor. No, it has lesser resistance. It allows current to flow. No, okay. So that's copper. What's uh, the opposite of of conductor, or
Insulator,
very
sir.
good, the insulator. Okay. So where is the insulator? If the insulator has greater resistance and the conductor has lesser resistance, so therefore they are opposite. No. Wh- where do you think you're gonna apply the insulator? Are you gonna apply the insulator in tandem with the conductor, or you're going to pair them both? And
Surrounding the ano po, conductor.
okay, very good. So there's a need to encapsulate the conductor, no, because of the presence of possible presence of electricity. No, if you're exposed with uh, an open conductor with an electricity, of course, there's a probability that you'll be electrocuted. So that's why we need the insulator to cover the conductor. Okay, so going back to the resistance, the greater resistance is found in insulator, and it will protect us from the conductor, no, from the metals, no, particularly copper. Okay, so we're just talking about resistance. Now going back to this circuit, I'm gonna teach you how to increase or decrease the value of the resistance. Let's say you're gonna hover the mouse and you notice that there's a change in color, then you right click, then you click edit. So I'm going to place 1000. Okay, can you see it? That I've changed it to 1000.
Yes, sir.
Okay, apply OK. Then you notice that the two, no, the two resistors now are experiencing the same amount of current, or the flow of the current is lesser, no, slower. Okay, am I clear with this Ohm's law demonstration? If you're going to
Yes, sir.
if you're
Yes,
going to
sir.
make it lower, now the
Yes,
resistance,
sir.
we're going to make it lower. Let's say 1 ohm is so very small, it's so very uh, small value, no, and you notice that the current is greater, no, compared to the 1 kilo ohm. Okay, okay, so we'll just set aside the equations. Okay, let's try to uh, delete. No, you just simply select all, or just the maneuvering of the mouse, selecting all the objects, then click delete. You can delete. Okay, so the next uh, topic is, we're done with the current now and the resistance, how to increase the current and increase decrease the resistance as well, and its effect. So we go now to the effect of voltage. Okay, so we're going to draw a circuit. So which do you think is the category for the for the voltage? It has something to do with sources, inputs and sources. So let's choose the DC person, the DC source, a two-terminal DC source. Okay, there will be a cursor. Then from lower potential to higher potential. So from you're gonna click and drag your mouse. Sorry, come again. I'm going to do it again. It's not. Uh, oh, there. Okay. Then uh, let's describe this first. What can you say about this symbol? Okay, so actually this is a voltage source. We're going to look at the description below. It says that voltage source I or current is equal to 0 ampere. So by the way, the unit of current is ampere. Then the voltage drop is equal to 5 volts. Then the power is 0 watts. Can you see it below? You can try
Yes,
to
sir.
zoom your coin. Okay, so this is a voltage source. If you're going to notice, there is two parallel lines. One is longer, then the other is shorter. Why do you think the other is longer and the other is shorter? Okay, it has something to do with plates. Okay, so batteries, no, particularly if you're going to open significantly a wet cell, if you're going to open a wet cell, then you can surely see plates. There are 13 plates, there are 9 plates, there are 17 plates, and so on and so forth. Okay, so that's why if you're familiar with wet cell, who's familiar with a wet cell battery, particularly the one that is found in vehicle or car, or it can also be seen in a motorcycle or even in a tricycle. No, have you seen a wet cell battery?
Yes po, sir.
Okay, so let's try to
Yes
search,
po, sir.
search wet cell battery. Oh, seems that my internet is slow. But anyway, let's continue. Okay, so typically an automobile has 9 plates, no? 9 to 10, I guess, or seven to 10 plates. And usually the charge is around 50 ampere hour, or there are also 70 ampere hour. Okay. Then for the emergency lights, there are 4 ampere hour, no? Small lead acid battery, no? With cell battery. Okay, so these are the plates. Now we're gonna add a resistor. So you right click the screen, add a resistor. Okay. Oh, I have now a resistor. Then you click again, right click, then you click the add wire. Okay, so I'm gonna click, hold, and drag. Okay, then click, hold, and drag, and release. The other side, click, hold, and drag. Okay, then click, hold, and drag. Okay, so what have you noticed? Did you notice anything?
Yes, sir.
So, is there a current flow?
Yes, sir.
Okay,
Yes,
so
sir.
there is a current flow. Why is that? Okay, because there is a battery, no, or what is known as a source, no, a voltage source. and you have a load, you have a form of resistor. You can also add a load. Let us say right click. Where is my LED? No, you can add also a LED or a lamp. Let us say, okay. Let's say let's try to connect this one. Okay. Make sure that you connect, you terminate the connection, the wirings. No, so it's there. Oh, there's a red dot because it's not properly connected. So you need to move this wire and connect it there properly. Then click, hold, and drag this one. Oh, click, hold, drag. Okay. So you notice that we have now two loads. The first one is the resistor, then the other one is the LED. Okay, and you can do that if you want lighting of the. But anyway, let's go back to the resistor. Now, what what are the ways how to increase the current flow? The first thing is we decrease the resistance.
The
Okay, so we decrease the resistance. The thing make it 10. Oh, we're increasing now current flow. Okay, so that's the one thing. Then let's go back to 1 kilo ohm. So decreasing the resistance will increase the current. What else? Just merely manipulating the equation. How can we increase the current aside from manipulating the resistance value? What else?
Increase the voltage po,
Ay,
sir.
very good. Very good. We are going to increase. So the question is, what is the current or the default value of the voltage?
Um, 5 volts, sir.
Okay,
Constant, sir.
you can see below, no? Can you see it below? So it's
yes.
there, the voltage
Yes
drop is
po, sir.
5 volts. Okay, so you simply right click, edit, and we're gonna make it, let's say, volt. Now, have you noticed that there is an increase on current? So in order
Yes
to
po, sir.
determine that, you're gonna hover the mouse over the element, no? The last time it was 5 milliamps. So this time it is 50
Mm.
milliamps.
Milliamp.
Okay, very good. Now the question is, why is it 50 milliamps? You can tell me. Is there a formula? Why is it 50
Uh,
milliamps? It's there, oh. The formula is there. It's 50
Voltage
milliamps.
divided by
Very
Voltage
good.
divided
resistance.
Okay.
by resistance.
The voltage is
Oh,
50. Okay. It's 50 volts divided by 1000 or 1K ohms. So therefore, that is 50 divided by 1, that is 50. And 1 divided by 1000 is milli, or 10 to the negative 3. That's why the answer is 50 milliamps. Okay, so you seems to master already the equation. No? It's just playing around with the equation and its effect. Okay, now what else can we do so we can increase the voltage, or no, rather the current, without replacing our battery. Now let us say this is our battery, no? And let us say this is 5 volts. We're gonna go back to the 5-volt battery or 1.5 volt battery. Okay. Actually, the 5 volts, but there's no 5 volts battery, rather, but 3.7, no, volts. And let's assume that there is a 5 volts battery. No. What can we do in order to increase the current without No replacing. By the way, changing the battery from 5 volts to 50 volts is, let's agree that it is a replacement. No, it's just simply replaced the battery with a bigger value. Okay? So you try to think about it. No, I need to drink water first. Meanwhile, you continue with the Tinkercad. I hope you opened the link and you created the account. Okay, I'll be back shortly. Okay, I'm back. Okay, so have you think about it? No, without, let us say, no, without replacement, the battery. Now, how can we increase? Now, besides the resistor, we simply replace the value or replace the resistor. No? How can we do it? Increasing the current. Now, I'm going to delete this part, okay? And I'm going to delete this one. So the answer would be adding, no, addition of additional, additional kuan. Uh, I'm gonna place this on top. Okay. So the alternative would be,
Adding up another source.
okay, you put up another source. Oh, who is it? Okay. Then let's say, uh, oh, what is it? Red. Uh, but anyway, it seems to be correct. Okay. Never mind the red one because it's registering a correct value. Okay, so we have now two sources, voltage source, 5 volts. Okay, two 5-volt sources with just 1 kilo ohm load, and we're enabled to increase the current. What's the current? Can you read the current?
10 milliamps,
Very
sir.
good. The previous was 5 milliamps. Okay, so let's further increase. Oh, let's try to move that one. I don't delete this one. I don't know why is it red. Duplicate. Okay. But anyway, you can always add from the one. Right clicking the one. Right click, add wire. Okay. So from 5 to 10 milliamps this time it is 15 milliamps.
15.
Okay. Now who can tell me now what scenario in your house, in your home, that there is adding of several batteries in order for a particular device to work? Have you
Remote
experienced?
control, sir.
Very good, no? Very good. Have you seen there are remote controls with one battery. But most of the remote control, no, had two batteries or more siguro perhaps. The question is, why do we need to add more batteries? By the way, why do we need two batteries instead of one battery?
Incon, sir.
The answer is already we've already answered the question, no, to increase the current.
Current.
Okay. Hello.
Yes,
Hello po.
sir.
Yes, sir.
Okay. So you agree with me that you need at least two batteries in a typical remote control for to increase the current. Okay.
Yeah.
Yes,
Okay.
sir.
Okay. Actually, in technical terms, you're not actually increasing the current. No? You're increasing its energy. Okay? Because current is dependent on resistance. Okay?
Mm, yes, sir.
Okay. So
Yeah,
take note,
sir.
we're just cause and effect. Because of the cause and effect, because you have two batteries, then you because you have two batteries, then the effect would be having a greater current capacity or current discharge current, no, you're able to produce more current. But then again, current is dependent to the resistance, because if you're going to let's say increase this to 3 kilo ohms, you know that the current goes back to milliamp. So that's what I'm saying, no? Even though you have three batteries, but the current is still 5 milliamps. So that's what I'm saying, that it's still 5 milliamps. It's subjective to the load. If you're if given a constant load, no, 1 kilo ohm, and you increase the voltage, of course you're increasing the current because your resistance is constant. No? Okay, so doesn't mean if you're going to to add more batteries, you're gonna increase the the current. It has something to do with the load. If your load is constant, no, now given the scenario, the first scenario, you have only single battery and 1 kilo ohm. If you're going to add battery, that's the scenario that you're going to increase the current. Okay? Am I understood?
Yes po, sir.
Okay.
Yes, sir.
It's not always correct to say that adding more batteries increases the current. Okay? It's not all the time it is correct. But what is correct is you are adding energy. Okay? Now, we know that batteries can store electrical energy. Okay? Agree, disagree?
Agree.
Okay,
Agree,
so
sir.
if you're
Agree,
gonna
sir.
add more
Very
batteries,
agree, sir.
okay, very good. If you're gonna add more batteries, it simply means that you're adding
More
more
Energy.
electrical energy. Okay? But in terms of cause and effect, as a consequence, because you have more energy, then will be possible delivering more current. Okay? But then again, this is subject to the Ohm's law relationship.
energy.
No, the resistance has something to do as well. Okay, so you just simply manipulate this equation. No, we have manipulated the equation, increasing the voltage by replacing the battery with greater voltage or potential difference. Then another one is putting several batteries. Okay, am I clear with this one? Then
Yes, sir.
another thing you can manipulate is the resistor, or rather the resistance. Changing the resistance will affect as well the voltage as, yeah, you can affect the voltage as well as the current, no, because of the equation. Now let's try to do that, no. Let's try to affect the 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 voltage as well. But before that, uh before we continue, let's review these three connections. The question is, what there are two general connections, no, in electrical circuit, series and parallel, or parallel or series. Now, which of the two connection is used in these three batteries? Will it be parallel? Is this in parallel connection or is it in series?
Series.
Okay, very
Series.
good. This is a
Series
typical
connection.
series, no, connection.
Series.
Yeah. Now in remote controls, you cannot see the series connection, no, but actually it is series connection, no, in the remote control. Actually, it's series because if you're going to remove one of the batteries, then it won't work. Okay, so that's series. So so in series connection, you're simply adding up the voltages. Let's say I'm going to edit this one, make this say, okay. So therefore, the voltage across this terminal, no, from this node, this wire in reference to this node down to this node, it's actually, oh yeah, oh sorry, okay, there is, anyway, the reference. Let's try the resistor. Let's make the resistor as a reference because the resistor is connected across from this, no, wire down to this wire. Okay, so you notice that if I'm going to hover or point the mouse on the resistor, what's the voltage now? The resistor. Can you see it, guys? You can try to zoom. Actually, you can zoom. Can you zoom? I don't.
Yes, sir.
So what's the value?
20.
Okay, very good. 20 volts. So which means if the batteries are in series, you're actually adding up their voltages. No, this one has 10 volts. This two has 5 volts. So 10 volts plus 5 volts plus another
10
5
volts.
volts. That's a total of
20.
20
20
volts.
volts. Very good.
20.
Okay. Okay. So let's try to do the other way around. Uh, we're going to do a similar, no, similar effect in store as well. Okay, we're gonna go back to 1 kilo ohm. Okay, then duplicate that one. Oh, sorry. We need to and right click and select drag, so that you can drag. Oh, we need to move this one. Click, hold, and drag. Okay. Oh, sorry. Okay, or might as well move this sister. Okay, right click, duplicate. Okay, then let's try to move. Oh, sorry. Okay, then add wires and let's try to edit the this one. Go back to the value of 5 volts. So we have now 5 plus 5 plus 5. So we have now 15 volts. Now, if I'm going to hover the mouse over this one, you notice that The resistor now has 5 volts instead of 15 volts. The second resistor now is also having 5 volts as well as this one, 5 volts. Okay, the question is, what is happening? Why is it that everything now is 5 volts? Guys, why is it 5 volts?
Because
Nag-add ka og more
if resist
resistor.
more
Okay,
resistance.
okay, so I have 3 loads already and it is connected in series. Now, seemingly, no, it has more or less the same effect. No? But the idea here is if you have a series connection, voltages will be divided accordingly. Okay? So what is our total voltage? It is 15 volts. Okay? 5 plus 5 plus 5. And we have 3 loads, equal loads. So that's why 15 divided by 3 is 5 volts. Okay? So let's try to increase, let's say, it won't be even anymore. Let's try to double this one. If I'm going to double this resistor, you notice that, oh, sorry. Let's try to delete this one. Going to notice now receiving 7.5 volts. Can you see it, guys?
Yes, sir.
Okay. Then this
Yes,
one
bro.
is receiving 3.75 as well as this one 3.75. Okay, so you notice the effect of the value of the resistance, doubling the resistance, which means doubling the voltage because it's there. Oh. Voltage is directly proportional to current. No, voltage is equal to current times resistance. So you could notice that voltage is directly proportional to resistance as well. Okay, since you double the value of the resistance, so in effect is you double also the voltage. No? That's why the voltage now is 7.5, which is double of 1 kilo ohm resistor 3.75. What is 3.75 times 2? That is 7.5.
7.5.
Very good. Okay? So the concept here is if you are going to connect, you know, the load in series, then the voltage will be divided. Let's try to uh, delete this one so that there will be only one series connection, which is actually the resistors are series with the source. Okay, and let's try to edit this one with 15 volt source. Okay, so you have now a 15 volt battery source. And let's go back again, review our resistors. The first resistor is receiving
7.5.
7.5. Then the rest are 3.75 and 3.75. Okay? So if you have a series network or circuit, voltage will be divided accordingly. Okay? Now, then let's make this circuit into parallel. So this is how you do things in parallel. Add the wire, connect. Okay, or you can uh, drag this one. Okay. Let's say, oh, it's not straight. Anyway, then, oh, Sorry. Okay, so therefore, in this configuration, it's the opposite of series. It's parallel. Okay, the 2 kilo ohm is in parallel with 1 kilo ohm as well as the other 1 kilo ohm. Agree, disagree?
Agree, sir.
Okay,
Agree,
so
sir.
who can tell me now the value of the voltage across 2 kilo ohm? It's just a guess. Take note, this is 15 volts. Can guess what's the voltage drop across the first resistor? It's just a guess. Will it be 5 volts? Will it be 10 volts? Will it be 7.5 volts? And so on and so forth. Low? It's just a guess. Okay, nobody.
5, sir.
Okay, so the answer is 15 volts. Okay, then the 1 kilo ohm is again 15 volts. Then another 1 kilo ohm, 15 volts. Okay, so if it is in parallel, the voltage is constant. I forgot the last time what is constant in series. What is constant in series? If
Well,
the
Sir,
voltage is
there,
divided accordingly, no, voltage is being divided in a series network, equally proportionally divided by its resistance. In parallel network, the voltage is constant. So, what is constant in series network?
electric current.
Okay, so in series network, the constant is current. Okay, it's the counterpart of the voltage. If it is not the voltage, then it must be the current. Okay, so here the voltage is constant. Okay, but the current is not the same. Take note, oh, the current for the first 2K resistor is 7.5 milliamps. The next resistor is having a 15 milliamps, and the third resistor is having also a 15 milliamps. Excuse me. Okay,
Yes, sir.
yes.
Yes, sir.
Yes, sir.
Yes po, sir.
now the question is, what kind of network do we have in our house? Will it be parallel or will it be series?
Series,
Parallel.
sir.
Okay,
Parallel
somebody's saying
series.
parallel, somebody's saying series. Okay, the question is, uh, let's try to agree to disagree. Now, did you bought a TV? No, did you have a TV with 220 volts, or is it 5 volts? Do you have a TV that has a 5 volts voltage? Is it 220 or 5 volts?
220,
Ah,
sir.
very good. Did you have let's say a fluorescent lamp or a lighting bulb or light bulb that is 5 volts or 220 volts?
5.
Again?
5 volts, sir.
5,
Oh, you have
sir.
a 5 volts lamp? Anyway,
220
okay,
gihapon, sir.
some are using 5 volts, no? Siguro if it is connected to a power bank. But if it is connected to the 220 volts, then it must be 220 volts. Now, another example, do you have what else? An electric fan. Do you have an electric fan? Is it 220
Yes,
volts or is it 5 volts?
Yes,
220.
sir.
Okay, so it seems that majority of our appliances or the rice cooker is
220.
as well 220 volts. Based on this data, no, gathered, what is your observation and conclusion?
The voltage is, ano,
Constant po.
sir?
Then, conclusion.
Parallel.
Okay, so we are using a parallel network in our home. No,
Home.
technically it's almost everywhere. Okay. Now, why is that so? Why are we using
By
uh,
constant the circuit.
okay? So one of the reason is that uh, in series network, if you're going to add something, you need to disconnect it first. Okay, so uh, let's try to uh, what is this? Perform, no? Let's try to perform. Let us say the resistors are your appliances. Okay, after all, your appliances have different resistances. Okay, if I'm going to add a resistor or add a load, did I disconnect the one the rest of the appliances? Let's try to connect. Add wire. Say, oh, I plug another appliances. Did I disconnect the rest of the appliances?
No, sir.
Okay, so I
No,
did not
sir. No,
disconnect.
sir.
However, if you do the other way around, okay, let's try to put them in series. Uh, let's not make so much series. Let's say only three appliances. Now let's say you have appliances that is currently let's say on, turn on. Need to delete this part. Anyway, oh, why is it a resistor? Right click wire. I guess I can insert it later. Okay, so let's assume are the first two resistors running or kuan active? Are the two resistors active? Or let's say that's the two appliances active already.
Yes, sir.
Yes.
Okay.
Yes, sir.
Now let us say the third appliance, I'm going to plug it. No, I'm going to use use this. How am I going? Oy, how am I going to do that? If I'm going to do it in a series connection, how am I going to do that?
You still have to insert it
Okay, so you
from
need
ano, sir.
okay, very good. You need to circuit or disconnect the circuit. Did I?
Yes, sir.
Okay, so I
Yes,
need
sir.
to disconnect the circuit. Okay, I need to disconnect. Oh, then after doing so, then that's the time that your third appliance or resistor is now active. So that is the disadvantage of having a
Parallel
series
circuit.
network, not a
Series.
parallel network, series network. Okay, so
Kaya basta
that's the
tapalan yung mga mapituan.
okay, so that's the reason why we have to do it in parallel. But the
Hindi
question
symmetry.
is, where can we use the series network or the series connection? If there are two types of connection,
Lights.
come again.
Lights po, sir.
Okay, very good. We're gonna apply it in Christmas lights. Agree, disagree.
Agree.
Agree,
Agree,
sir.
sir.
Agree.
Again,
Agree po.
so let's assume that we have a light, no, in the form of a LED. And the source is DC, no, direct current or battery. Okay, so let's just assume. But anyway, we go to outputs and labels, no, and add a LED. What is a LED? It's a light emitting diode. Okay,
Diode.
then might as well duplicate this one. Let's say let's say make it four. No? let's try to drag, connect it there. Oh, gonna click and drag. Okay. Am I connecting it in series or parallel?
Series.
I very good.
Series.
Series.
Here, sir.
Okay. Oops. Then lastly, we got the other wire because it's short. Oh, there we go. We have now a series lights. Agree, disagree.
Agree, sir.
Agree.
Agree,
Now
sir.
the question is, why do we
Agree,
need
sir.
to series the Christmas lights and not do it in parallel?
Plus, they have to be connected, sir.
Yeah. Don't you know that
Basing
Chris
Mobuto po, sir.
Chris very good. Okay. Because you notice the lights of the Christmas light as compared to fluorescent lamp or the light bulb, no, standard light bulb in our home is bigger as compared the Christmas light. Is this true?
Yes,
Yes,
sir.
sir.
Okay.
Yes.
So the size of the device is most of the time directly proportional to the power requirement of the device. So simply saying that if you have a smaller device, then it is surely, no, most probably consuming less power. At the same time, requiring lesser voltage. Okay, so let's check. What's the voltage of this one? Oh, it's overwhelming. Let's try to adjust our. Let's say you have a 12 volts. No, not 12 volts. 6 volt rather. Let's try to check 6 volts. Oh, it's not preferred. Let's 9 volts. Let's try 9. 9 volts. Oh, it's still overwhelming. It did. Instead of 9, let's try 7. Just for the sake of the experiment. Okay, 7. Or why not make it 8? 8, how about 8? Oh, it's too much. 7 is, let's make it 7.5. How about 7.5? Oh, again, it's too much. 7.1. Okay, that's it. That's fine. Okay, so I adjusted the voltage because usually the typical uh, the average current for a LED is around 10 milliamps, and if you're going to read the current now, it's 9 milliamps. Okay, can you see it? So therefore, we're operating in a
Yes, sir.
normal. It's not over current, no, normal current. Okay. So what can you say about the voltage of the LED? It's 1.775, or let's say approximately 2 volts. Let's say, anyway, 1.75 will do. Okay, or 1.775. Okay. Now, what will happen if you're going to make that in parallel?
Constant lang po ang vote.
Okay. So, what will happen if I'm going to do this in parallel? So, let's try to check what will happen. Take note, the nominal current for a LED is around 10 milliamps. If we're going to exceed 10 milliamps, there's a probability that it's going to explode or it's not nominal. Okay. Or is it connected? Okay. I'm going to connect it in parallel. Oh, can you see now the current? What can you read about the current?
Over 100 po,
Oh,
sir.
okay.
Five.
It
Hanggang
takes
five
Ah,
hanggang sa
it takes 1 to 10 milliamps to kill a person. Okay? It takes 1 to 10 milliamps to kill a person, but this one it's 100 ampere. Surely, no, it's out of range, no. So it's gonna explode the device. So what's the solution? You have a very small light and requiring small voltage. So what is the solution?
you have to use series connection po, sir.
Good. No? Because you're going to divide the voltage. That's the main reason why you need to put it in series because you're dividing the voltage. Okay. What happens if there's only one lead? Now let's say if there's only one lead. Wait, the resistor. I'm sorry. Right click, add a wire. What happens if there's only one resistor? It's the same thing. You're exploding the Christmas light, the single Christmas light. Okay? So to overcome or to solve this problem, in order the Christmas light will not be exposed to over voltage, what's the solution? You put several, you add several LED in series.
Resistor, sir.
Okay, so
LEDs.
we hold first on adding a resistor. We take that later. Yeah, it's possible to add resistor, but the resistor is just consuming power without generating light. Might as well to add a
LEDs po
LED
or device.
to convert electricity into useful output, which is the Christmas light. Okay? Oh, there you go. So you divided the voltage is now 1.775. So the solution for having a series connection because you want to divide the voltage. Okay? Now it's correct to say that you're gonna add a resistor. Yeah. Okay. Let's say we're gonna remove the three. It's also correct, no? You can technically uh, use one single LED, no, directly connected to a 220 volts, provided that you have a resistor. You notice that it's 5 milliamps. Okay, so provided that you have this one resistor, but the problem is if it is going to be inserted in a series light, no, most like it will be just consuming energy without translating it to useful, such as brightening up, uh, such as a light, no, a light converting into light. Okay, correct that you can use a resistor. Now, after all, just simply to resist the current. No? You need to resist the current in order to arrive around 10 milliamps. But going back to our uh, no, we need to put this in series, not parallel. That's why Christmas lights are in series. Now, the next question. Let's assume that this is okay. Let's assume that this is uh, assume that this is 100, no, 100 lights around. How long is it? 20 feet? No, no, 6 meters. Let's say 12 meters. 12, for the sake of argument, 12 meters. We assume that this is our 100 lights and it has 12 meters. Okay? So let's tackle first the 100 lights. What if I want 200 lights?
24 meters, sir.
Now, forget first about the length. No, forget about the 12 meters. Let's tackle first the 100 lights. What if I want to have 200 lights?
Insert more current. I
More
The
current and more.
question is, I want 200 lights. What will I do?
add more current.
Add more
Add more
current,
source or
Come
lead.
come
power
again.
source,
Add more.
power
Source
source.
or lead.
Let us
Source.
say, yeah, okay. Let us say that it's another assumption. Now we're using a 220 volts. You can no longer add uh, voltage source, no, because that is our nominal source, no, in our home. Unless you want to set up another transformer or a three-phase transformer for you to have 440 volts or so. But anyway, that's out of the question. No, we just focus on the 100 lights with just 220 volts, and I want 200 lights. So what will I do?
Increase ang voltage.
Okay, so that's out of the question again. We have only 220 volts. By the way, do you have a 440 volts appliance in your house? In your home? Do you have?
Wala.
Ah,
Wala.
wala. So it's out of the question. Okay. So let's focus on a constant voltage source, which is 220 volts. And we cannot do it. We cannot change it. No? Because actually we can change it, but it's impractical. Let's look at the practical side. Okay. Of course, we can do it. No? But it's impractical. Let's do the practical side. So given 100 lights, you want to make it 200 lights, what will you do?
Another source po, sir.
Oh, you don't have another source. You have only 220 volt source. Okay, so the idea is to use your series and parallel network. Okay, you apply the concept of series and parallel. I'm going to redraw the circuit because it's impossible for me to have more than. Okay, might as well delete everything. Oh no, not delete everything. Okay, okay, I'm gonna do it horizontally. Okay, I'm gonna do it horizontally. Oh, no. Yeah, there. Okay, I'm gonna do it horizontally. Okay, adding copy and paste. It's very good. Oh no. Okay. Oh, is it broken? Yeah, it's broken. It's connected. Okay, so let us say we add another 100 lights. Okay, we add another 100 lights. Okay, take note, it's just an assumption because it's so difficult for me to prepare 100. Actually, it's possible, but it's physically, dimensionally impossible. Okay. So the question is, what went wrong or what happened? Take note, this is 100 lights, 12 meters, then another. Oh, is that another? Another. Okay. Okay, what's the scenario? we have 200 lights placed in series. But what happened?
The lights didn't turn on, sir.
Can you read
Yeah.
the current?
Ang current, wala nag-kuan, sir. Wala nag-move.
Yeah, but you can read the current.
921 po, sir.
What's the unit? Carabao?
Nanoampere po.
How small is nanoampere? It's 1 divided by 1 billion. Is that something small or big? The
Small.
reciprocal of 1 billion, ah. The multiplicative reciprocal of 1 billion. Is it small or is it big?
Small, sir.
Okay.
Very small.
So the problem now, so let's analyze. So it's almost, it's 24 meters. I make it 24 meters already. But I make it also in 200 lights, but it doesn't make sense because it's not a Christmas light. Agree, disagree?
Agree, sir.
Okay, so
Agree.
what's the solution? I'm gonna disconnect this one.
Ay mo para
Ay, very good. Imuho na tong parallel ang unsa. Unsa na to? Unsa imuho na parallel? It's a very
Ang 100
technical
lights po,
question.
sir.
Ha?
Ang lights ko.
Ang
Ang
unsa?
100 lights po, sir. 100 lights.
Okay, so we're going to make the two networks in parallel, not the individual elements. Agree, disagree? Okay, so
Agree.
the idea here is to make it
Correct, sir.
parallel. So I don't know if you can see how I'm going to connect it in parallel. Tanawa. Uh, anyway, I'm gonna connect this one. Okay, so this one, I'm gonna add a wire and connect it in the other side. Oh, it's short. Okay, oops. Okay, then this one, I don't know if I'm gonna able to connect this one. Okay, move this one. Oh, I'm not moving it. Uh, drag, drag. Oh, sorry. Then I'm gonna now. Question: is it parallel? Is the two network in parallel?
Yes, sir.
yes, sir.
Yes, sir.
Yes, sir.
But are they in series?
Yes, also.
Yes, sir.
Okay, so technically, the solution now is having a series network at the same time, having a series connection at the same time having a parallel network. Okay, that's the only solution you can increase your Christmas lights.
Vol-
I don't know if you have seen a Christmas light that has at the other end it has a female plug or socket rather. Diba? If you've seen the Christmas lights has a male plug and the other end it has a female plug. Okay,
Yes, sir.
that's
Yes,
the
sir.
idea. You make a parallel connection, no?
Yes, yes, sir.
Okay? So I hope you you get the idea of having a series and parallel, no? Not everything seems to be series is in series and not all everything seems to be parallel is always parallel, particularly in dealing with Christmas lights. Okay? Because it has limitations, no? Siguro it can handle 100 lights within 220 volts. So adding additional lights would decrease the current as well as the voltage for each light. So might as well create another no series lights and connect it in parallel. And it seems to be series, but actually it's not only series, it's also using a parallel network. Now the series and parallel and Ohm's law, current, voltage, and resistance are the very essential things you need to know before one, handling sophisticated devices, no? Such as a microcontroller. Okay, it's a very sophisticated device. Then let's say different sensors. Okay, you need to understand when to use it in series, when to use it in parallel. Okay, now the resistor, how to add it in series and how to add it in parallel. Okay, so these are the important things that need to be discussed prior to having uh, a very complicated advanced circuit. Okay, so do you have any clarifications? I want to follow up on your Tinkercad. What's the update? I'm gonna uh, go back.
Excuse me, sir.
Okay, let's try to see if I have already students. Okay, let's try to click.
Excuse me, sir.
Yes.
Sir, unable kayo kung makasulod, sir, kay masking tulo ka
Ay,
Gmail lang
very
ang
good.
gigamit sa dili
Very
dili
good.
lagi na
No,
tawag.
sorry. Very good because there's so much here view, but it seems that I don't know how many of this. It's not that intelligent enough to tell me how many students I have. But anyway, try to use Facebook. Oh, be
Mga
it's not updating my not
naangwan, sir.
updating my I want to check the updates. Oh, I have 26 students. The question is, how many are you?
Yeah, 7 for both sessions, sir.
Come again? 27?
7, 70, sir,
Oh,
for both
70, but only
sessions.
26 students have enrolled in
Sir,
Tinkercad.
Can we have the code again po, sir?
Okay. So actually, I didn't delete the code. It's there in your uh, Google Meet. Can you try to click the chat? You need to click that link. The You look for the timestamp 9:16. Can you see it? 9:16.
Mawala po siya
wala siya, sir.
on this next, sir.
Please.
Okay, so I need to post it again. Okay, for a while,
Yes, sir.
I
Thank
need
you,
to
sir.
copy class code. Okay, there you go. Copy link. Okay, actually, you can screenshot the code. No, but it would be faster if you click the link. Provided you have already signed up with Tinkercad.
Sir.
Yes. Did you see the
Will.
post
Yes, sir. I did na, sir.
timestamp 10:42?
Yes,
Okay,
sir.
what's the question?
Na, still the same, sir. Mas mo sa Facebook, sir. Mangayo siya email. Tapos, pag ibutan ako kung email, sir, bigyan po niya dawatan. Hindi po siya na invalid na email address.
By the way, why do you have an invalid email address? My suggestion
I don't know.
is you make a new
Another one, sir?
email address
Uh,
because it's an invalid. I don't know why it is invalid. What makes it invalid? Is it Gmail?
yes, sir. Sa tulo. Tulo ka
Ah,
Gmail.
oh, you have already three Gmail?
Yes, sir. 3 Gmail ang isa yung pwede po siya.
Hmm, I don't know what happened. Try Yahoo. I don't know. But anyway, uh, Did you add me in our Facebook group so that from time to time you can ask question, post?
Yes, sir. I already made a
Okay,
group
so
chat.
group chat. It must be a Facebook group. But anyways, yeah. If it is a group chat, yeah, you keep on kung ano, browsing up and down the the group chat. But anyway, can you which is better, group chat, group page? Can you also make a group page? No. Anyway, a group chat will do. No, group chat will do. Okay, open request info messaging. Where is it? Okay. Okay, sabi, let's try to put the link here. Okay, that's the link. Then for the file start, no, for the file start, where is it? So that's the example. That's the last example of our series circuit.
Sir Jerry,
Yes, sir.
kining masyada siguro group page na lang sir kay pag naman ko kay post sa group chat tabunan ba sa conversation
Usually, mana may
kailangan sa mag-back
mana,
ha
mag-backread gid sila, sir. Kaya mami lang mo.
mag-backread sila.
Backread gid mo. But anyway, I
So pag
instructed them to create a group page as well, no? Facebook page. Guys, you need
okay.
to create Facebook group page as well, no? Aside from this group chat, because the advantage of the group chat is you don't have a load, you can still chat. Diba, guys? That's the reason siguro why I created
Ah,
the group
sige
chat.
po, pwede.
So let's have the two, no? The two version.
Tapos sir,
Yes, sir.
paliw lang ko inform sa uban nga napay wala nag-attendance.
Okay, guys, you need to fill out the attendance.